Ever walked into a lab and watched a colleague stare at a centrifuge that just doesn't seem worth the price tag? You've probably felt that tug of doubt. Do I really need a high-speed benchtop model? Or am I just throwing money at a piece of equipment I'll barely use? It's a real worry, especially when you're balancing a tight research budget against the need for reliable spin-down performance. I was in the same spot last month, scrolling through dozens of options, reading spec sheets, and wondering whether the extra horsepower actually translates into everyday value. Link is in the description if you want to check the product details on Amazon. The benchmark Scientific Z036HK landed on my radar because it promises a super speed of up to 395G while staying compact enough to sit on a regular bench. That sounds impressive, but the real question is how that power plays out when you're actually separating plasma, pelleting bacterial cells, or preparing nucleic acid extracts. I dug into the user manuals, talked with a couple of lab managers who have similar models, and tried to map the specs onto the kinds of protocols you see in a typical molecular biology or clinical chemistry workflow. First off, who should consider this machine? If you regularly run high-speed protocols, think viral pelletings, subcellular fractionation, or rapid spin-down of viscous samples, then the Z036HK's 65000G sealing can shave minutes off each run. That may not sound like a lot, but in a 96-well plate format, those minutes add up quickly, especially when you're on a tight deadline for next-day sequencing. The benchtop footprint means you can tuck it into a standard workbench without needing a dedicated floor stand, which is a blessing for small labs or shared core facilities where space is at a premium. On the flip side, if your routine revolves around low-speed spin cell culture harvests at 500G, occasional blood plasma separations, or routine PCR cleanups, the extra force is overkill. You'd still get the job done with a more modest and typically cheaper centrifuge that tops out at around 15,000G. In that scenario, you're paying for speed you'll never really need, and the budget could be better allocated to consumables or additional sample prep tools. One of the most practical strengths of the Z036HK is its auto-rotor recognition. You load the rotor, and the software instantly identifies which model you've attached, adjusting the acceleration and deceleration curves accordingly. In a busy lab where multiple users swap rotors throughout the day, that feature eliminates the guesswork and reduces the chance of human error. I've seen labs where a misprogrammed deceleration caused sample spillage. With auto recognition, the instrument handles those parameters for you, which translates directly into less wasted time and fewer cleanup incidents. The optional high-capacity swing-out rotor is another point worth mentioning. Swing-out designs keep tubes horizontal during spin-up, which is crucial when you're dealing with delicate gradients or when you need uniform sedimentation across the tube length. The high-capacity option lets you process larger tubes up to 50 ml without compromising the force. For a protein purification core, that means you can run larger prep batches in a single spin, reducing the number of cycles and the wear on the tubes. In practice, I've heard users say the ability to go from a 15 milliliters tube to a 50 milliliters tube without swapping equipment saves a lot of procedural friction. However, there are hidden trade-offs you won't see on the spec sheet. The swing-out mechanism adds a few extra moving parts, which means you have to be a bit more diligent with maintenance. The manufacturer recommends monthly inspections of the swing arm bearings, and in environments with high humidity, you might see a slight increase in noise over time if the lubrication isn't refreshed. It's not a deal-breaker, but it does add a small maintenance overhead that you should factor into your total cost of ownership. Another practical consideration is the programming interface. The advanced programming sounds sleek, but it's really a touchscreen menu that can feel a little cramped if you're used to a full-size keypad. The auto recognition helps, yet when you need to set custom protocols, say, a stepwise ramp up to 30,000G for a delicate virus concentration, you'll find yourself scrolling through several screens to input the exact ramp times. For power users who love tweaking every parameter, the learning curve is modest. For occasional users, the default presets cover most common protocols, but you'll still need a quick cheat sheet on hand for the less frequent custom runs. In terms of value, the headline figure of 395G is attractive, but the real ROI comes from the time saved on high-speed protocols and the flexibility of the swing-out rotor. If your lab's throughput hinges on quick turnaround, think clinical diagnostics where you need to spin blood samples and get results within an hour, the speed advantage can be the difference between meeting a deadline and missing it. Conversely, if your workflow is more relaxed, you might not feel the urgency to invest in that level of performance. So, should you buy it? If you're a small to medium-sized research group that frequently runs high-speed spins, needs a compact footprint, and